Atomic radius. Atomic radius is the average distance between a nucleus and the outermost electrons. Usually this is measured as 1/2 the distance between two nuclei of an element in its elemental form. So two of the same elements, if I were to draw this element, and I'm just going to put a dot for the nucleus, but imagine there are protons and neutrons in there. And then I'm going to draw another element, the same element, and then I'm going to draw this line between them. Okay, so this line between them. And what the atomic radius measures is actually half that distance. So because they're radii and they are the same length, these two things should be the exact same. So radii means that anywhere, if I pointed out that radii from anywhere, it would be the same distance. So that's what atomic radius is. We can use the periodic table to notice trends that happen to different elements and their atomic radii. So, periodic trend for atomic radius is atomic radii decrease from left to right across a period in the periodic table. So as I go from left to right in this direction, I decrease my atomic radius. And that makes sense because as I get more and more protons, I have more attractive force for the electrons that are in the same energy level in that period, so I can draw them closer to me. So it is very easy to see that protons, when you have more protons, keep adding protons when you move from left to right, you are decreasing the distance because you're pulling them closer. Atomic radii increase, though, from top to bottom. So as you go from top to bottom, it increases because now you're adding more energy levels and more orbitals. So as you move up energy levels, the atomic radius gets further away because even though you have more protons, it's not necessarily enough to attract them closer to you because you are moving up energy levels. So here's another way to look at it on the periodic table. As I move from left to right, I am decreasing because I decrease the atomic radius size, so I'm getting smaller and smaller. These things are getting smaller and smaller because I have more protons at that same energy level. So C has a smaller atomic radius than B and has one smaller than C, and so on and so on. As I go down, though, I increase. So as I go down, these elements get bigger and bigger and bigger. The distance between the nucleus and the outermost electron increases. So Na has a bigger atomic radius than Li, K has a bigger atomic radius than Na, and so on and so forth.